All right, so on the 2018 test, the question number 5, of all the questions I've ever seen, this one probably has the shortest introduction. And then we kind of jump in, and you're like, okay, it's got a lot of pi, and there's one idea in particular. I was like, holy cow, you're supposed to do that, because it technically should be done without a calculator. So the first question says, the introduction says, let f be the function defined by f of x equals e to the x cosine of x. And that's it. So what we do for letter A is find the average rate of change. Well, the average rate of change is y2 minus y1 over x2 minus x1 for any function, okay? Now, again, if you were looking for average value, then you would do an integral. But because this is average rate of change, I've got pi, I've got 0, and to find y2 and y1, I just plug those in. So I've got e to the pi times the cosine of pi minus e to the 0 times the cosine of 0. And that technically, you can leave your answer like that if you want to. If you simplify it down, you get like e to the pi minus 1 over pi. But you don't need to do that. And you're not going to need this later in the problem. So we're good on letter A. Letter B, what is the slope of the line tangent to the graph at x equals 3 pi halves? Well, what that's asking for is it wants the derivative. So to take the derivative here, I have to use the product rule. So e to the x times negative sine of x, that's first times the derivative of the second, plus the second times the derivative of the first. Then I just plug in 3 pi halves. So I get e to the 3 pi halves times negative sine of 3 pi halves plus cosine of 3 pi halves times e to the 3 pi halves. Now, technically, when you plug that in, the cosine of 3 pi halves is 0. And the sine of 3 pi halves is negative 1. So really the answer, if you want to simplify down, you don't have to, but you get e to the 3 pi halves is what that would simplify down to. You don't need to. This answer right here is sufficient. But if you did simplify that, this is what you'd get right there. Now this is the problem. When I saw this initially, I was like, holy cow, like that is so difficult. Because I want to know what is the absolute minimum value on 0 to 2 pi of this function. So you're like, oh, okay, absolute minimum value, that's not that bad. I'm going to look at my end point, my start point and my end point. And then all of a sudden you're like, wait a minute, and this is where this gets difficult. I have to take my derivative that I just found right here and set it equal to 0. I know that's not exactly right, but that's more or less what it was. Set that equal to 0 and solve it. Now, I'm just going to go through how to do that real quick. In order to do this, you factor in e to the x out. Then you get negative sine of x plus cosine of x is equal to 0. Okay? Well, e to the x never equals 0. And what this is really asking is, where does the cosine of x equal the sine of x from 0 to 2 pi? Not something that I think a ton of people know off the top of your head, but that happens at pi fourths and 5 pi fourths. So what I have to do now is I have to take 0 and I have to plug it into the original function, then pi fourths, 5 pi fourths, and 2 pi, and find out which one gives me the smallest value. When I plug 0 in, I get 1. When I plug 2 pi in, I get e to the 2 pi. These are the numbers that are really difficult. I'm going to get e to the pi fourths multiplied by the cosine of pi fourths, and e to the 5 pi fourths multiplied by the cosine of 5 pi fourths. Now with the calculator, this is not that big of a deal because you'd figure out that only one of these is actually negative. This is the only number that comes out to be a negative, so that is my absolute minimum value. The problem is most people, I don't know that they would get that right away because that is a really difficult question. You have to know a whole bunch of stuff about trig. So that one was tough. I mean, again, the numbers look bad. If you plug this, you're supposed to be doing this without a calculator. It's what makes this problem very, very, very difficult. Okay, with a calculator, definitely doable. Without, it's bad. Then we look at letter D. Letter D says, we've got the differential function g of pi halves is equal to 0. We want to find the limit as x equals pi halves of f of x over g of x, or state that it does not exist. Well, in order to do this, what we have to do is we have to say, okay, I'm going to go f of pi halves over g of pi halves. It tells us in the problem that g of pi halves is 0, and since this is a limit problem, you can pretty much guarantee that that is going to be 0 as well, so we have to use L'Hopital's rule. L'Hopital's rule says that we take the derivative. Remember, the derivative here is e to the x times negative sine of x plus cosine of x times e to the x. That's my derivative of f of x. And then I've got a graph of the derivative of g of x on the bottom. So there's g prime of x for the bottom using L'Hopital's rule. Then I'm going to plug in pi halves. So I'm going to get e to the pi halves times negative sine of pi halves plus cosine of pi halves times e to the pi halves. And then I look at my graph of the derivative and I can see that g prime of pi halves is 2. And luckily for us, we can leave our answer like that. Now, this problem was rough because you had to know a whole bunch of stuff about trig. Again, if you knew your trig values, this problem's not that bad. Or if you have a calculator, it's easier. I still think this is one of the more difficult problems we've seen just because of the amount of trig that exists in it. But hopefully it kind of made sense as we went through it what you're supposed to do. If you have any questions about this problem or any others, please let me know.